everyone, my name is Kisha. The topic that I'll be discussing on is volume of a watermelon.
Hello everyone, my name is John. The topic that I will discuss is electric charges.
Hi everyone, my name is Muhammad Shakir. The topic that I will discuss is distance, velocity and acceleration. So the first example related to distance, velocity and acceleration. An important application of this principle occurs when we are interested in the position of an object at time t, say is on the x-axis, and we know its position at time t0. Let st denote the position of the object at time t is distance from a reference point, such as the origin on the x-axis. Then the net change in position between t0 and the t is st minus st0. Since st is an antiderivative of the velocity function vt, we can write st equals to st0 plus integrate v u evaluate from t0 to t. Similarly, since the velocity is an antiderivative of the acceleration function at, we have vt equals to vt0 plus acceleration u evaluated t0 to t. The question is, the acceleration of an object is given by at equals to cos pi t, and its velocity at time t equals to 0 is 1 over bracket 2 pi. Find both the net and the total distance traveled by the object in the first 1.5 seconds. Now, let's proceed to the calculation. The first part of the question asks for the net distance traveled in 1.5 seconds. We need to take the highlighted formula and substitute acceleration equation, which you can find from the previous slide, and the value of velocity when times is 0 to get the equation for velocity at time t. So the equation for velocity at time t, when we substitute all the values, we will get 1 over pi open bracket 1 over 2 plus sin pi t and close bracket. Then we take this equation and substitute in the distance formula to find the net distance traveled. We will integrate the velocity evaluated from 0 to 3 over 2 to get the value of the net distance traveled, which is 0.340 meter. After that, we continue for the second part of the question, where the question asks for the total distance traveled by the object. We need to take note that in this part, when will the velocity be positive and negative? In this case, the velocity will be positive when time is less than 7 over 6 seconds. So we just integrate the velocity evaluated from 0 to 7 over 6, and we will get the distance traveled during this period is 0.3747 meter. For time more than 7 over 6 seconds, the velocity will be negative. Thus, we need to add modulus to positive the value of the distance at the end. So we integrate the velocity evaluated from 7 over 6 to 3 over 2, and we will get the value of the distance traveled during this period is 0.0347 meter. Lastly, we just need to add both of the distance value to get the total distance traveled by the object, which is 0.4094 meter.
Then let's move to another example. The second example is related to electric charge by integration. The force between charge is proportional to the product of the charge and inversely proportional to the square of the distance between them. Fx equals to kq1 q2 over x square, where q1 and q2 are in the column, x is in meters, the force is in newton, and the k is a constant with its k equals to 9 times 10 power of 9. It follows that the work done when electric charge move forward is other, or when they are separated, is given by work equals to integrate from a to b kq1 q2 over x squared dx. The question is, an electron has a 1.6 times 10 power of negative 19 C negative charge. How much work is done in separating through electron from 1.0 pm to 4.0 pm? Okay, then we proceed to the solution for calculation. If we recall back, the pm main picometer or 10 power of negative 12 meter. In this example, we got the value of A equals to 1 times 10 power of negative 12 meter. The value of B equals to 4 times 10 power of negative 12 meter. Then the value of K equals to 9 times 10 power of 9. Then the value of Q1 and Q2 are same with each 1.6 times 10 power of negative 19 C. Then we have the formula of work with each integrate from a to b k q1 q2 over x squared dx. So we integrate the value with is 1 times 10 power of negative 12 to 4 times 10 power of negative 12, and we get the final answer with is 1.728 times 10 power of negative 16J. Thank you.
Watermelon has an ellipsoidal shape with major axis 28 cm and minor axis 25 cm. Historical approach. Before calculus, one way of approximating the volume would be to slice the watermelon, let's say in 2 cm thick slices, and add up the volume of each slice. Interestingly, Archimedes, the one who famously jumped out of his bed and ran down the street shouting, "Eureka, I've got it!" used this approach to find volume of sphere around 200 BC. The technique was almost forgotten until the early 70s when calculus was developed by Newton and Lebris. The question is, a watermelon has an ellipsoidal shape with major axis 28 cm and minor axis 25 cm. Find its volume. Hi everyone, today I'll be discussing on how to solve question number 3. Before we ever get into the calculation step, which is the most interesting and tricky part of this chapter, I would like to give a very brief explanation on how are we going to actually solve this question. So the method that I will be using to solve this question will be historical approach. It's basically before performing integration. One way to approximate the volume of watermelon would be to slice the watermelon, let's say in 2 cm thick slices, and add up the volumes of each slice using the formula V equals to pi r square h. So, and you all are well known that V equals to pi r square h is actually the formula for volume of a cone. So that's why we are using this formula, because when you cut the watermelon into slices, it actually forms the shape of a cone. So that's why we can use this formula to calculate. So the next part will be is the integration part. We know that the melon is an ellipsoid, therefore we need to find the equation that is suitable for us to integrate. So first step will be we have to let A equals to half length of the major axis and B will be the half length of the minor axis. Next, we use the general equation for horizontal ellipse, which is x squared over a squared plus y squared over b squared equals to 1. And then the last step will be we actually can form the equation by making y squared as the subject, since the watermelon is an horizontal ellipsoid, therefore it rotates 360 degrees about the x-axis. Then basically you can look at the calculation steps where you actually equate the denominator to get the y squared as the subject. Then we can substitute the value of A, which is 14, and the value of B, which is 12.5, which I get from dividing the major axis and the minor axis with 2. So the last part of the video will be the integration part. So the value of A and B we use for ellipse is not the same A and B we use in integration, because the region bounded by the x-axis we're actually supposed to be referring to the major axis. So in this case, the region bounded is from 14 to 0. So next we can just perform the basis integration step where we will substitute the value of 14 and 0 and then multiply with 5 to get the final volume. But finally, the volume that we get has to be multiplied with 2 because just now we find the volume for just half of the watermelon, not the full watermelon. So we just times with 2 to get the final volume, which you can give in centimeter cube or in liter as NT. And then this is about the same as what we got by slicing the watermelon and adding up the volume of the slices, which is in the shape of cone, right? So basically for this question we are performing using two methods, which is first we use the ellipse method, we actually use the ellipse formula and also the integration formula. That's all. Thank you.